Good morning. Yeah, it's still morning. It's 11:30, April 7th, I believe. We're going to talk about, let me go back one, chapter 14, working drawings. I might do all this in one setting instead of four parts. There's only, only 21 slides. So we'll see what's happening. First thing you can do is go over the objectives. We're going to talk about top down, bottom up, middle out design. Discuss methods of constraining assemblies made using solid modeling and parametric modeling. Number 3, identify the elements of a detailed drawing. 4, list the parts of an assembly drawing. Number 5, list 6 types of assembly drawings. Number 7, list the role of the record strip and the title block in the approval process. Describe the process for revising drawings and describe the special requirements of a patent drawing. Okay. So, this is a working drawing or a construction drawing. The term working drawing describes a set of assembly drawings and detail drawings, a set of civil drawings with site, grading plans, and many structural details for a building a dam or bridge is an example of a working drawing. Architectural drawings are another type of working or construction drawing. And this drawing right here is actually a floor plan of an office building, it looks like. It's got, we've talked about layers in the past. This drawing probably has dozens, if not hundreds, of layers. And because each one of those little symbols and colors and whatever represents some different layer. You have your basic floor plan layer, which would be your black, I guess that's there, or a grayish, your dark gray color. And then you would have your other layers. You have your text layers, that red that describes things within the building, the doorways. Maybe points out the doorways. The green is HVAC, the ductwork. Okay, and then there's like an orange color. That's also HVAC. That's the return air. The greenish color is a supply air ducts, and the orangish color is the return air ducts. Okay. Here's another example of a working drawing or assembly drawing. This is an air brake assembly. You have the drawing itself. You have a over on the upper left, you have a looks like a front view and a right side view. And then you, for whatever reason, you have, it looks like a couple of isometric drawings pointing out different things. Upper right hand corner, you have, what is that? That's a revision. Yeah, that's a revision. The table there's about 4 or 5 revisions there that some, along the history of this drawing, somebody's made changes to it. The lower left is the parts list, or the BOM, bill of material. And it's got each part has a number, which corresponds with that item number. If you look on the drawing itself, you see what we call balloons. Those are circles with numbers in them, and they're pointing to some specific part. And so you would go down to your BOM, or your bill of material, and find the item number. There's a quantity. How many do you need of those pieces? You have the part number for each one of those parts. And then you have a description for those parts. Then, of course, down in the lower right-hand side, you have your title block. And then here's an assembly. This is the assembly drawing shows the assembly machine or structure with all the detailed parts in their functional positions, or as an exploded view where you can relate the parts to their functional position. So actually you got a front view on the left, and the right side view is actually a section drawing. Okay, and it shows the internal workings of the machine. And this looks like a grinder. Yeah, a grinder assembly. Okay, down in the lower left you have I'm assuming that table is probably like a revision. They call it correction, but I'd say it's sort of like a revision table. And then on the right hand side you have your title block down at the bottom right corner, and above it you have your bill of materials with all the part numbers, item numbers. You have description, you have quantity, and then you have another column that basically tells what the material that part is made out of. This is another assembly drawing. There are different types of assembly drawings. Design assemblies or layouts, general assemblies, detail assemblies, working drawing assemblies, outline or installation assemblies, and inseparable assemblies such as weldments and other type drawings, I guess. Okay. This is actually a 3D modeling. Okay, 3D CAD model for an air brake. It says, I don't know if it's a SolidWorks drawing or an Inventor drawing. It's one of those two probably, or it could be a CATIA drawing. I'm not familiar with that much with CATIA drawing. Okay. Here are detailed drawings or piece part drawings. Drawings of an individual parts are called piece part drawings or part drawings or detailed drawings. Most of the time they're either going to refer to as part drawing or a detailed drawing. Detailed drawings contain all the necessary information to manufacture any specific part being created for a product or design. So this is heat sink, fend, beam, dump, truncated, wherever that is. Okay, but it's all the information on that. It's not a assembly drawing. It's a part drawing. It's one of the parts drawings that will be used in a assembly drawing. You got some notes in the lower left corner. You have a revision table up at the top right corner. And you have all the parts with all the dimensions and notes and stuff required to make that part. Sub-assemblies. A set of working drawings include detailed drawings of individual parts and the assembly drawing showing the assembled unit. So here are the parts. This is actually a half section, except on that far right. Actually, that's a full section on the far right. But the upper half on the left is a half section because the lower half is a regular orthographic projection drawing. And instead of having a parts list or a BOM, bill of material, you have all the you have arrows. Instead of balloons, you have arrows pointing one up to the description of each part. For example, in that top left one, it says a nut. It's what it looks like, a 3/8 24, probably a fine thread nut. And it's got an arrow pointing down to what appears to be a nut on the inside of that section view. Identification. These are your balloons, okay? Circled numbers called balloon numbers or ball tags are used to identify the parts in the assembly. Circles containing the part numbers are placed adjacent to the parts with leaders terminated by arrowheads touching the parts. So you have, in this drawing right here, you have, looks like 8 parts, or 8 different parts. It's got multiple, some of the parts have multiple parts of that. Like number 8 has, looks like 5. Number 8 has 5 parts. So you have the balloons up there in the upper left there. You have a description of how to draw those balloons. If you use a circle that's 0.44, which is 7/16, you would use a 0.12 number in the middle of it. That's 1/8. 0.12 is 1/8. And on the right hand side, if you use a 1/2 inch or 0.5 1/2 inch circle, you would put in a 0.19 or 3/16 inch text in there. Multi-detail drawings. When multiple detail drawings are shown on one sheet, label each part with an identification similar to that used on way detail drawings. That is used on way detail drawings. Okay, trying to figure out what that exactly wording meant. Anyway, you have part number 1 and part number 2 there. They're on the same drawing, but they're labeled separately. And and then in the right hand corner above the title block, you have the bill of material. And number 1 is a secondary base, and number 2 is the collar. Okay, if you're working with 3D modeling programs such as SolidWorks or Inventor, you're going to get a table like this on the left, and you will put the necessary information in that those boxes there on the left. And when you get done, you'll have a bill of material shown in that dialog box above there. A parts list or bill of material itemizes the parts of a structure shown on an assembly drawing. So when you put it on the left there, when you fill out all those little boxes there, and when you look at your drawing, your finished drawing, you'll have a bill of material list like that on the right hand side. Instead of having to draw all those lines and stuff like that, the SolidWorks, in this case it's a SolidWorks drawing, would actually do it for you. You just got to put the information there necessary. There's assembly sections, and an assembly section is necessary not only to show the cut surfaces but also to distinguish between adjacent parts. Do this by drawing the section lines in opposing directions. So along the top there, you have a single part on the left, and all your section lines are drawn the same way. In the middle there on the top, you have 2 parts. If you notice, the section lines are drawn in the opposite direction. And on the right there, on the upper right, you have a drawing of 4 parts sectioned, and you notice they're all either opposite direction and they're drawn at different angles. Then you have, in the lower right hand corner, you have a solid hatching small parts. That heavy black line at the bottom, that's probably a gasket of some sort, and then you look like you have a couple of rivets there holding it together. And then on the left you have symbolic section lining. Again, you have some threads, internal threads on the top parts. This is another one of those half sections. And the bottom is drawn like an orthographic drawing, but the upper part is drawn in a section view. And you have internal threads. You have look like something like a countersink screw there in the middle and above you. So you notice they all have different. The section lines are all different. Here's another 3D drawing. This is probably an inventor drawing because it's an Autodesk. Actually, it's not even, it's a drawing on the right. But Autodesk, well, you can download your suppliers for standard parts. So instead of you having to draw that part out, it's a standard part. You buy it off the shelf. You can go to this website here, this CAD modeling selection, and find your part and click on it, and you get to see it in an actual drawing, or maybe even download it to your drawing so you can have a print of it. Other assemblies. After all detailed drawings of a unit have been made, it may be necessary to make a check assembly, especially if a number of changes were made in the details. A working drawing assembly is a combined detail and assembly drawing. So over on the right hand side, you have a working drawing is combined, has detailed information and assembly drawing all in one package. And the problem there is it becomes very busy, very confusing, and that might not be the best idea to do that, but they had their reasons to do it, so they did it. On the left there, it says an assembly made specifically show how to install or erect a machine or structure is called a installation assembly. So how is this assembly, how is it put together? So that's what this drawing, you notice only has about 4 dimensions on it, and all that's there for is to show you how this stuff, how it's supposed to fit together. Working drawing formats. There are 2 general methods for regrouping detailed parts on a sheet. Showing one detailed part per sheet is typically preferred because it is easier to repurpose drawings for other uses and to track revision data when the sheet does not contain extra parts. So this drawing right here is actually from the previous drawing on the right. It's a working drawing and a detailed drawing. And like I said before, with being a detail and a working drawing, it gets very cluttered up, very busy, and very confusing. That's why that note above it says it's typically you want to show these parts on separate drawings. And what they're talking about up there is if you show these on separate drawings, and if you ever want to use these parts in other assemblies, you could do that. And if you ever made changes to these individual parts, it's a lot easier if they're done on an individual part drawing. Digital drawing transmittal. Using electronic files saves trees, makes it quicker to distribute and store documents, and allow others to review documents from various applications. Okay, this is a PDF. Okay, this is PDF, it says there on the left there, is originally developed by Adobe in 1993. It's a while back. It says you can, the originator, can send this document to, it can be commented on without allowing the original document to be changed. So they sent this to a client probably, or if it's an engineering department, sending it to the manufacturing department. They're going to look at it and they're probably going to put notes, those little red clouds on there with little notes, just telling them what they any issues they may see with that drawing, and they can send it back to, like, for example, the engineering department or the originator, and have them fix anything that's wrong. Title and record strips. The function of the title and record strip is to show in an organized way all necessary information not given directly on a drawing with its dimensions and notes. So these are the following 8 things, primary things that you want to look for in a title strip or a record strip. You want the name of the object. You want the name and address of the manufacturer. You want the name and address of purchasing. If you're purchasing, you want that company's name on there. Signature of the person who made the drawing and date of completion. You want the checker and date of completion. I think I've talked to you about the checkers. If you're in a large engineering firm or a company that has a lot of drafts persons or designers in there, they're going to have somebody that's very experienced working as a checker. What they do is they mark up your drawings just like I do when I mark up your drawings and turn them back in. Well, you have the same thing in business, because they're wanting to minimize any mistakes that's made. So that checker, that's their job, to make sure your drawing is correct. Okay. And then you have the signature of the chief drafter or a chief engineer or any other official, and the date of approval. Okay, if you're working in a small firm, you're probably just going to have you'll be working for an engineer. They're going to tell you what they want. You go draw it up. You give it back to them. They look at it. They mark it up. They give it back to you, and you fix it and you give it back to them. And hopefully they'll sign off on it, and you can send it out to be made or built. You want the scale of the drawing, and you want the drawing number. Checking drawing. So here's the final checker. Okay, here's the checker guy or gal. Should systematically review the drawings for any remaining errors. They should study the drawing with particular interest to, or attention to, soundness of design. In other words, is it going to work? With reference to function, strength, materials, economy, manufacturability. Can it be manufactured? That's just like if you're sending something to a machine shop, they got to be able to do and machine it, okay? Serviceability, ease of assembly, repair, lubrication, and so on. Choice of views. Did you choose the correct views, the number of views, partial views, auxiliary views, section, lettering, and so on. Dimensions, with special reference to repetition, ambiguity, legibility, omissions, errors, and finish marks. Attention should be given. Special attention should be tolerances. So there's those tolerances again. That checker is going to be paying a lot of attention, because they got to make sure things will fit together properly. To talk about repetition with dimensions, you don't want to repeat dimensions. You want to minimize your dimensions. You want enough dimensions to make the part, but you don't want too many. They'll run into problems later. Standard parts. In the interest of economy, as many parts as possible should be standard. It's a lot easier to buy this stuff So, anything you can buy off the shelf, it's going to be to make your life uh, better. It's going to, make it easier, and just always check to see if there's not already parts out there. Notes. Make sure you have notes with special reference to clear wording and legibility. Make sure if you've ever read something that doesn't read right, there was something in this in one of the previous slides here that I couldn't quite make out what they were talking about, and it's because the wording wasn't clear. Make sure it's clear and legible. Clearances. Moving parts should be checked in all positions to ensure movement of parts or freedom of movement. Okay? You don't want it bumping into anything, or it might lock it up and cause the part to break or whatever like that. And then your title form information, make sure it's fully filled out. Drawing revisions. The record of revisions should show the change, by whom, when, and why the change was made. An engineering change order, which is sometimes called an ECO, or an engineering change request, which is an ECR, is processed to approve and track changes to drawings once they have been released for production. Okay. Sometimes when you draw something up, you don't catch everything. Even the checker or the engineer doesn't catch everything. And when you send it out to the manufacturing, to the plant that's making the part, and they start actually making the part, they run into issues. And so that's what these engineering change orders or change requests are about. They send those requests back to you. It's a formal way of documenting what needs to be done. If you're in construction work, like an architect, you draw up a set of plans. You got all your engineers, your electrical, your HVC, your mechanical engineers, all the engineers, your civil engineers, they're all working on these drawings, and they get very, very, very complicated. And for the most part, they do a pretty good job of catching everything and in their design work. But once they send it out to the contractors to start building, those contractors are going to run into issues. And so that's what they do. They send back through a change order, okay, back to the architect. And those architects and engineers, their engineers will document the change and make the changes and send the drawings back out. Sometimes that costs extra money, okay? But that needs to be done. Any changes or additions made to a drawing are attracted by a revision number. A symbol can be added to the drawing showing the item affected by the revision. So in your revision table, you're going to have a number, and it's going to be have a corresponding number by where the change is. Sometimes you can make a little cloud. They put little clouds around the item that's changed. That way it kind of stands out when you see it. And then you could have notes here that says, like the drawing, if you make a new drawing, and the old drawing's still around, you can stamp it with obsolete or put obsolete on it. Or you can put a superseded by the new drawing. It's replaced by that new drawing. Okay. Simplifying drawings. It makes sense to reduce drawing costs by using practice to simplify your drawings without losing clarity. Okay, these are 10 suggestions on how to simplify your drawing. Use word descriptions when practical. Okay, describe it verbally. Do not show unnecessary views. Do not draw any more than you have to. Use standard symbols such as the diameter symbol, I think it's called theta, and standard abbreviations. Avoid elaborate pictorial or repetitive details. Use phantom lines to avoid drawing special or repeated features. Okay, so don't repeat. Don't make big fancy pictorial drawings. Okay, keep it simple. Number 5, list rather than draw parts such as bolts, nuts, and keys and pins. These are stock items that you can get off of the shelf. You don't need to draw them. Okay, so just make a list. Omit unnecessary hidden lines. Okay, if the hidden line is not contributing anything to the drawing, leave it out. Number 7, use outline section lining in large areas to save time and improve legibility. Number 8, omit unnecessary duplication of notes and lettering. Yeah, don't overdo your notes and lettering, just like dimensions. Don't overdo dimensions, because if you duplicate notes and lettering and somebody makes a change, they may not make a change, change all the notes and lettering, and somebody's going to read it wrong, and you're going to make a part wrong, and it's going to cost money and time and material, all that stuff. Number 10, use CAD libraries and standard parts when feasible for design and drawings. Always try to use standard parts, and always check your CAD library for any standard parts that you can buy. Okay, the last drawing, or last slide in this, and probably the last slide for this class, is pattern drawings. We're going to talk about patents for a few minutes. Drawings for patent applications are pictorial and explanatory in nature. Therefore, they are not detailed as working drawings for production purposes. Center lines, hidden lines, dimension, notes, and so forth are omitted, since specific dimensions, tolerances, and notes are often not required to patent the general design of the innovation. So these are examples of patent drawings. Okay, the patent drawings office. If you are an engineer, I don't know if it's still this way, but I was told years ago that if you have an engineering degree and you go to work for the patent office, they'll send you to law school so you can get a law degree. Okay, that's just a side note there. Patents are very important. I may have talked to you about the guy in the Chattanooga area that built the socket wrench, or designed and patented the socket wrench, and Sears back when